Where did the geysers on Enceladus come from? Launched into space in 1997, the Cassini probe was a joint venture between NASA, ESA and the Italian ASI. It reached Saturn 7 years later. In 2005, it approached Enceladus, one of the gas giant's moons. Then she noticed a thin atmosphere and geysers spewing out, among others, water vapor that fired the imagination of astronomers. They indicated the presence of liquid water under the icy crust of Enceladus. However, scientists from Dartmouth College at a meeting of the American Geophysical Union suggested that the water may come not from the subsurface ocean, but from pockets or crevices in the moon's icy crust. The subsurface ocean makes Enceladus one of the best places to look for life in the solar system. Concepts for future missions to Enceladus are based on the assumption that it will be easy to collect samples of material ejected from geysers and will allow direct testing of the contents of the ocean below the ice, without having to drill or melt ice to get to the water. But new simulations suggest that the water discovered by Cassini may come from the moon's surface, rather than from a subsurface ocean. This does not change the fact that collecting and testing samples in possible future missions should not be difficult, but as Jacob Buffo of Dartmouth College pointed out, it may not be the same chemistry as in the ocean. When the spacecraft returned the data to Earth in 2005, scientists wondered if the jet of geysers came from Enceladus's icy surface, where friction caused by quakes could melt the ice and allow it to escape as water vapor into space. However, the subsequent data collected by Cassini has convinced most scientists that the geysers originate from cracks in the moon's icy crust that extend all the way to the salty, subsurface ocean. Colin Mayer of Dartmouth College admitted to the American Geophysical Union meeting that one of the most compelling evidence for a subsurface ocean on Enceladus was that the plumes contain salts. The first concepts explaining the presence of water by friction caused by earthquakes could not cope with the presence of salt. They suggested that any salts from the melted ice would remain on the surface as the water escaped into space, like a layer of salt on the skin left behind by sweat during intense exertion. But Mayer, whose scientific interests centered on the physics of sea ice on Earth, realized that the meltwater reservoirs in the ice crust could concentrate salts and other compounds. He and his team used computer simulations developed to study sea ice on Earth to the observed ice conditions on Enceladus. The team found that various processes on Enceladus could easily generate pockets of watery mush in the icy crust and release their contents into space, along with salts and everything else they contain. That doesn't mean Enceladus doesn't have an ocean, it almost certainly does, Mayer says. However, the implications of the simulation results could be extremely important, especially for proposed missions to search for life on Enceladus. If the detected plumes of matter are not from the ocean, it will really change our perspective on what they tell us about Enceladus' interior. And that's a big deal, says Emily Martin of the Smithsonian National Air and Space Museum in Washington, who was not involved in the work. The presence of plumes of water vapor coming directly from the ocean would require cracks throughout the moon's crust. However, as scientists from Dartmouth College point out, 24-hour stresses are not enough to form such cracks in the ice crust. Enceladus is a relatively small moon of Saturn. It is 504 kilometers in diameter. It is the sixth largest natural satellite of this planet. It was discovered in 1789 by the German astronomer William Herschel. It is a very interesting object. It is completely covered with ice. This means that it has the highest albedo, the ratio of reflected to incident radiation, in the entire solar system. Previous findings also suggest that under its icy crust there is a huge, salty ocean that covers the entire Moon, and its depth can reach up to 60 kilometers. The source of heat that keeps water in a liquid state may be tidal heating resulting from the change of shape of a celestial body by the gravity of another similar object. Cassini measurements also indicated that the plumes appear to be the result of hydrothermal activity on the ocean floor. This, of course, fired the imagination and led to debate about whether the Moon's ocean could be suitable for life. In the plumes of matter ejected from Enceladus, scientists have found, among others, nitrogen and oxygen, which play a key role in the production of complex amino acid molecules that serve as the building blocks of proteins. Without proteins, life as we know it on Earth could not exist. Scientists also found hydrogen, carbon dioxide and methane in them. How much does the soul weigh? McDougall's controversial experiments. In 1907, American Medicine published a paper by Duncan McDougall suggesting that the human soul weighs 21 grams. The author came to these conclusions after experimenting on a small group of dying people. These studies were rejected by the scientific community and to this day arouse much controversy. But nevertheless they took root in mass culture and popularized the concept that the soul weighs 21 grams. The very concept of the soul is more equated with religion and the afterlife, not science. And depending on the religion, the soul is interpreted differently. But also scientists are dealing with this issue. The best known, albeit negative, example is Duncan McDougall, a doctor from a small town in Haverhill, Massachusetts, USA, who worked there at the turn of the 20th century. McDougall was fascinated by the soul. He wanted to place it in the human body, measure it, weigh it, characterize it. He rejected the concept of the soul as an immaterial being. He claimed to be a material body organically connected to the human body and that he could prove it experimentally. He hypothesized that the soul could be weighed and attempted to do so by measuring the weight lost by a person at the time of death. The experiment is widely regarded as flawed and has no scientific value due to the small sample size, the methods used, and the fact that only one of the 6 subjects met the hypothesis. Added to this are the ethical issues of the experiment with dying people. Despite being rejected by the scientific community, McDougall's experiment popularized the idea that the soul had weight. Specifically that it weighed 21 grams. McDougall conducted his experiments several years before the publication in the prestigious periodical, American Medicine. Anyway, this article was a response to the criticism that appeared after the New York Times described his experiences in March 1907. The doctor was experimenting with what he called the soul substance, which he believed was in the human body. He believed that since human personality and identity exist, they must inhabit somewhere in the body. Given the belief based on the Christian religion that the soul is immortal, at the moment of physical death of the body, it must somehow leave the body. This in turn led him to conclude that the soul must have mass and that it can be determined by weighing a dying person. In 1901, he began to look for seriously ill people whose lives were coming to an end in nursing homes. He found 6 such patients. 4 had tuberculosis, 1 had diabetes, and the last one had no diagnosis. At least there is no information about it. Then he turned to their families, asking them to consent to the experiences in the last hours of their loved ones' lives. McDougall specifically selected people who suffered from conditions that caused physical exhaustion because he needed the patients to remain still on their deathbed so that their possible movements would not interfere with the measurements. When patients were near death, their bed was placed with them on an industrial scale, which McDougall described as 5.6 grams. The results of the experiments were inconclusive. Other people, including at least one doctor, accompanied McDougall in his experiments. The first of the men in the experiment was placed on the scales 3 hours before he died. During this time, there was a steady loss of weight, which was explained by the loss of water through sweating. The moment of death itself was described by McDougall as follows: when life processes ceased, the opposite scale suddenly fell. It was astonishing and it looked as if something had suddenly lifted from the body. He then estimated that the body had lost 21 grams. McDougall was convinced that he had measured the mass of the soul, but as he himself pointed out, it was one measurement and another should be done. The next volunteer was also a man suffering from consumption. At the time of death, McDougall reported a weight loss of just over 14 grams. In both cases, the doctor could not explain the weight loss with medical knowledge. In 1902, McDougall performed 4 more similar experiments. In 2 cases, the weight loss was 10 and 14 grams. The third measurement was interrupted by people demanding that the controversial experiments be stopped. In the last case, the weight of the dying person did not change, which the doctor explained by the fact that the patient had been placed on the scales 5 minutes before death and that the scales were still being calibrated. This fact reduced the value of the experiment, so the researcher did not take it into account when drawing conclusions. It should also be noted that among the mentioned cases, one first lost weight, only to gain it after a few minutes. In the case of 2 others, McDougall noted a loss of weight. But a few minutes later the patient's bodies lost even more weight. It appears that McDougall only accepted the first patient's measurements. The loss of 3/4 of an ounce, 21.3 grams, coincided with his death, he believed. And since he could not explain it otherwise, he decided that this is what the soul substance weighed. McDougall probably would have continued his experiments, but he worked in a hospital and was forced by his superiors to stop experimenting, believing that humans have souls and animals do not. McDougall performed similar experiments on 15 dogs that are now believed to have been killed for weight. McDougall reported that none of the dogs lost weight after death. When the article in the New York Times appeared, criticism poured out on the author of his experiments with dying people, but over time readers divided into supporters of the doctor and his opponents. It was different in the case of publication in the scientific journal, American Medicine. In this case, the article caused a discussion in the scientific community regarding the fact that the text was allowed to be published at all, because the results of these studies in the article were not confirmed or explained. The immediate rejection of the research by scientists meant that the scientific community did not pay much attention to these experiments. Criticism focused primarily on the morality of the author of the experiments with dying people, but also on the numerous shortcomings from the point of view of the scientific method. His contemporaries invoked the ancient Egyptian concept of psychostasis, a symbolic motif of weighing the soul in art during the final judgment, in which the soul is assessed as to whether it is worthy of salvation. However, they pointed out that this concept implied a moral evaluation of the soul, not its material importance. Others joked that McDougall proved that the soul has wings, because how else could it get to heaven? Although the author in his publication pointed out that the density of the soul is much less than the density of air and does not need wings to float in the air. However, the basic objection raised by many was that the loss of a person's body mass at the time of death does not necessarily have to do with the departure of the soul. Back in 1907, the American doctor Augustus P. Clarke noticed that at the time of death, there is a sudden increase in body temperature because the lungs stop cooling the blood, which causes increased sweating, which in turn may explain the loss of weight. Clarke also pointed out that because dogs don't have sweat glands, they don't lose weight that way when they die. The fact that McDougall probably poisoned and killed 15 healthy dogs in an attempt to validate his research was also met with criticism. Critics also pointed to numerous problems with the research. The main one is to accurately determine the time of death. From the published correspondence between McDougall and Richard Hodgson of the American Society for the Study of the Supernatural, to which McDougall belonged, it appears that the doctor himself had problems with this, especially in the second, third and sixth studies. Another issue is the equipment that the researcher used in his measurements. McDougall, as is clear from the letters he wrote, recognized this problem. The fifth patient experienced problems with the operation of the scale. There were also irregularities in the fourth and sixth cases. It is currently difficult to determine what happened more than 100 years ago in McDougall's laboratory. But only the first experiment seems to have been successfully performed without any complications. Modern researchers also refer to experiments from a century ago. The Japanese physicist Masayoshi Ishida stated that McDougall's experiments are worthless because they cannot be repeated for ethical reasons, which is the essence of science. Because the impossibility of repeating an experiment and obtaining the same experimental results suggests that these were the result of errors, fraud or accident. He added that McDougall's experiments would not meet the standards accepted in modern science. First of all, the group of subjects was too small. It consisted of 6 people. Too few measurements were made, and the instruments used at that time were not very precise. In any objective experiment, such problems would have led to the cancellation of the study. And probably no sane scientist would even brag about the results obtained, but that did not stop McDougall from drawing conclusions. The experiments penetrated the collective consciousness due to the moral controversy surrounding research involving seriously ill, dying people, and due to the fact that they concerned alleged evidence of the existence of an afterlife.